This tutorial will cover how to design and 3D print an adapter for the Rev motors. First thing I'm going to do is I'm going to navigate to this year's class in my folder. I'm going to go ahead and save. We call it a Motor Spacer. I'm going to save that in my folder. This has to be saved for me to import an object. I'm going to come over here to the main robotics folder, click on Rev Robotics, and this is the motor that we're using for the mechanic wheels. So I'm going to go ahead and right click on this and say insert into current design. And that's going to bring that motor into my CAD workspace. I'm going to 3D print this, so I want to put my spacer here on the end, and I want that to be facing up, so I'm going to go ahead and rotate that 90 degrees before I get started. And that's going to bring in a copy of the Rev motor. Next thing I want to do is I want to draw on this surface right here. The problem is that as we bolt down to these bolts, this spacer and all this stuff in the center gets away. So we just want an adapter that sits on top of here to help us with the spacing. So I'm going to go ahead, hide the data panel. I'm going to come over here to my Rev motor. I'm going to right click on this and break the link. I want to make sure that if I accidentally make changes to this, that it's not going to corrupt and make changes to the main copy of the motor in the Rev folder. So next I'll come over here. I'm going to right click and say new component. We'll just leave all these as the default values. This comes over here, makes a new component, and activates it. All I want to do is create a sketch. And I want to create a sketch on this top surface here. You'll notice if I hover over here, you can kind of see the graph paper behind there. But when I hover on the surface, even though it doesn't look like it sees the surface, it adjusts the coordinates and it's going to draw on this top surface here. So I'm going to select this top surface as my drawing face, and you can see it turns it to the top view, and there's a ton of stuff in my way. So I'm going to go back to the angle view. First thing I'm going to do is I'm going to create, and I want to include an intersection. I'm going to make sure this is on the specified entities, and I just want this face in my sketch. I'm going to say OK, and I'm going to come over here to the Rev motor. I'm going to turn off the eyeball and get rid of that rest of the body. It's still there. I just don't need to see all that stuff and get in my way. If you want to look back, you can see this is where the main bolts are attached to the motor. We don't need to mess with any of that stuff. We're going to bolt onto here. So now I'll turn this to my top face. And first thing I want to do is I don't want to have my 3D printed brace right against here. The 3D printer, since it extrudes plastic, makes things a little bit bigger than normal. So if I just leave this as my circle, it may not fit around that. So I'm going to come up here to the offset. Let me go ahead and select that circle. And then hit offset. It's going to move it out 0.0397. We're just going to type in 0.02 as our offset, and that should be more than enough. The next thing I need is I want a big circle around here. So I'll create a center diameter circle here, and I'll just come out and snap to that outside circle. And then I want to come over here to these circles. I want to leave room so we can get to these. They're 0.09, so I think we can, we still want to be able to put screws into those. So if we just make them 0.1, that's a little bit small. We'll go 0.12. That should be large enough. Okay. And then since that's so easy, I'm just going to type in 0.12. Circle command 0.12. 0.12. And that should be enough for the screw to get through there. So I'll go ahead and finish that sketch. I'll go back to my isometric view, start the extrude command, and I want to select all of these portions here. And that's what I want to extrude. We'll start with just 0.1 inches upward. And now I've got my spacer ring. So I can go ahead and save this. And what we're going to do next is we're going to take this to Prusa Slicer and slice it. Now that we already have it designed and saved, you come over here to Tools, come over here to where it says Make, click on the triangle, click on 3D Print. For my selection, I'm just going to go ahead and select this. It's the only thing we made. Select OK. It's going to ask me to save it as an STL file. So we'll go ahead and call this Motor Spacer. And save this somewhere where you can find it. I'll go to my documents. I have a box folder, as you can see. You can save it wherever you need to. Put an ultimate goal in Motor Spacer. The next thing I want to start up and look at is Prusa Slicer. This should be a fairly easy. And go ahead over here to File. Import STL. I have to go back to wherever I saved it. Grab that Motor Spacer file. It's going to bring it in really tiny because we designed in inches and it thinks it's millimeters. The conversion is 2540. That's the how many percent bigger. We hit enter. And that's my Motor Spacer. So we can print this out of PLA. You can do 0.2 layer height and slice this. And it's only going to take 10 minutes to print. And you'll see it kind of gets really thin right there. Print one of these, and then if it does not fit, if it's too big or too small, we can come back here to the model view. I'm going to uncheck the scale factor, and instead of being locked, I'm going to unlock it. And then on the Z height, I can just come in here in the Z height. This is 1.27 millimeters. If this is too big or too small, I can just come in here and type 2 millimeters and hit enter. Whoops. Oh, that's position. So sorry. Size. I can come over here. It's 2.5. I can type 3 and hit enter. And it just makes it a little bit thicker. And if that's too big, I can come in here and type 2 millimeters and hit enter. And it definitely shrinks it back down. You can re-slice it and try 3D print another one. So to get the height correct, you can just come back to the size factor, make sure that they're not all linked together. Otherwise, it's going to shrink the X and the Y as well. And then these are just going to take 10 minutes to print. Make sure we get one the correct size, the correct Z height that we want. And that way we've got new spacers for the motors. Thank you.